Hey, my name is Scott Lydon, and you're watching Swifty. I'm going to show you step by step how to make a pokedex app which shows Pokemon with their pokedex ID in a table view. And I'm going to explain what's going on, and we're also going to use closures. We're going to talk a little bit about MVC. We're going to also use an API. We're going to parse some JSON. So let's get into it. So let's create a new project. We'll click Xcode, and then you can either do File and then New Project, or you could do Command-Shift-N, and I like using the hotkeys when I can. And we're going to choose Single View App, and we're going to name it Pokemon Table, and you can really name it whatever you want. So let's just run the app. I'm going to run it on iPhone 8 simulator, and I'm going to take this out. Don't need all that. And here's the simulator. So I'm just going to drag this a little bit so I can click between the two. Now, the storyboard, I'm going to have a table view. So, oops. Let's drag this up. There we go. Okay, table view. Table view controller. I'm going to take out this table view controller. That view controller. And I'm going to make this the initial view controller. And drag that a little bit. There we go. I'm going to give it a reuse identifier as cell, and I'm going to drag in a label. Now the first one is going to be number, or the yeah, that's fine. And then that I'm going to make a little bit bigger, and alright, and now I'm going to drag in another label for, this will be the Pokemon. Label. So this one, I'm going to make it a little bit bigger, and this one, also going to make a little bit bigger. And this one I'm going to make a little bit gray. Alright, so I'm going to create a view controller class, and I wish they put subclass of before class, because if you give it a name and then you change it, it changes what you named it. So if you name it TVC and then you change it back to view controller, it adds view controller on it TVC. It's pretty annoying. So you should choose the subclass first. UI table view controller, and we're going to call it Pokemon TVC, and I clicked enter and create, and now we have our table view controller. And I'm going to take all these things that we're not going to use for this. Don't need the number of rows per section because the default is already 1, and that's exactly how many we need. Oh, whoops. Oh, did I delete the wrong one? Oh, number of sections is the one we can delete because the default is 1. And let's say we're going to have an array Pokemon, and we're going to call it Pokemons just to be funny. And it will be an array of, alright, let's create the Pokemon class Pokemon, and it's going to have a name property, var name, and it's going to be a string, and var number, and that's also going to be a string, or actually it's going to be an int. Number comes first in the view, so I'm putting it accordingly. And this is going to be an array of Pokemon. Alright, and that equals, let's see, is it going to be an empty array? Let's make it a struct. That's what I meant to do. Okay. Struct has default initializers, so we don't have to worry about creating initializers for it. What is that? Oh yeah. Okay. Class. Oh yeah. Okay. So Pokemon's. Oops. Pokemon's dot count. That'll tell the table view controller how many rows to put in the table view, and it'll be equal to the number of Pokemon we have. And now we want to do we want to define the function cell for row at. It's a function that is called by the table view, and we are going to let a cell equal table view dot dq reusable cell with identifier as, and it's actually going to be a of type UI table view cell. So we're going to force unwrap that because we're confident that it's there. And we didn't use it, so we should return it. Now, cell. Now we need to create a UI table view controller cell. UI table view controller, or UI table view cell. Excuse me. There we go. Pokemon TV cell. And I'm going to create that. Okay, now we are going to, actually we don't need any of this. So I'm going to connect that cell to its class, Pokemon table view cell, and now I'm going to, and this. It really doesn't want to give that to me. Okay, so we're going to go to the cell, and here we're going to connect the number pokedex none, and we're going to connect the label, which will be and we're creating that right there. All right, cool. So now we're going to cast it as the Poco TV cell. Oops, let's get out of this view. So, all right. So we're going to say as Poke TV cell. Oops. Oh, stop that. Poke TV cell. All right, cool. So now we can access those properties on it. Poke. Oh shoot! Come on. I'm gonna clean. Oh yeah, I'm gonna clean this, and I'm gonna build it, and then I'm gonna save it. Now it should access the properties on it. There we go. All right, Pokenumber equals Pokemon's, and then we're going to use the subscript and use index path dot row. And because we're using multiple ones, I like doing this. Let row equal index path dot row. And now we don't have to write index path in there. We just can write row. So cell dot Pokelabel equals Pokemon's, and then row. And because this is a struct, we're going to use the number here, and then we're going to use the name there. All right, now this is a nicely set up table view controller. Oh, right, okay. Text, got to assign it to the text, and then this one should be like this because text is a string, so we have to convert the number to a string. We're going to call a function called getPokemon, and this is the function that's going to get Pokemon to display. So it's saying we haven't created getPokemon, and so it is telling the truth, as it often does. Pokemon. All right, now this is the function that's going to call a function in another file, and I'm going to create that file right now. URL API call, and all right, cool. So we're going to make a singleton. So we'll call it class API call, and it's going to have a value static let shared equal an instance of itself. Private, it's going to have a private initializer. takes no parameters and returns none as well. And, oh, excuse me, does not require parentheses. Okay, I'm going to call this function Pokemon. And what it does is it's going to take a closure, and I'm going to call it completion because it's a closure that will be executed when this function completes. And it's when I use the word completion, it doesn't have any significance for the code itself, but it makes it a little more readable so other developers can see completion and have an idea that it might be something that's run when the function is done executing its body. Or, oh, it should be a type, takes an array of Pokemon and returns nothing. Let me see if this will work. Will that work? I don't think it'll work. No. Okay. That's right. The parameter list needs to have the tuple parentheses. So we're going to send in an array of Pokemon, and where does it go if we did have a return? Let's say we had a return and it was string. Where would that string go? Would it go in this function definition, or if we were to call it, let me delete that, and if we were to call it from here, API call Pokemon, instance member Pokemon cannot be used on type API call. Oh, yeah. Okay, so when you call a singleton, you're going to use actually the property on it. So I'm going to use API call, and then instead of calling the function directly, I'm going to use shared. Now I should be able to call Pokemon, and it takes a completion handler. So I could just press enter, and because it's the last one, it took off that completion. And now I'm going to call this Pokemon's, and it returns a string. But if I return a string here, then it'll be implied that it returns a string, and then I don't have to have that there. Now I just have this kind of nice, neat syntax. And let's see if it builds. Command B, and it builds. So that means there's no compiler issues. Now, okay, so I can have my API call, and then I can get my Pokemon here and then send them over to be used over here. And so actually I gave away the answer to the earlier question. So if the completion that you're passing into this body returns a string, where does that string go? Does it go to the definition of this function, or does it go to the definition of this closure? We're going to have to write it here, but the string returns back to here. So we can print completion, and it'll print hey when we run it. Oh, oh yeah, we have to give Pokemon. I'm going to define Pokemons. There we go. One Bulbasaur. Sour? Okay. First. Alright, there we go. Now we have an array of Pokemon. Only has one in it. That's okay. It's still an array. And now this is going to print hey. So I'm going to run this. Let's open up that debugger. Oh no, it didn't print hey. Let's see if it gets reached. I'm going to stop it and then run it. I think what's happening is, yeah, that's not getting reached. Oh, of course not. Did I assign this? No, I did not. All right, there we go. Now let's do the scan. So basically what happened was I didn't assign the table view controller to the table view. So it is reaching it now, so I'll press play and it prints out hey. So this print statement, before trying to print anything, it says what's inside this these parentheses. So then it says, oh, it has a call to this function. Let's call it. Then it passes in Pokemons, jumps all the way over to the closure, and then it sends those Pokemons here and then lets you access them. I didn't really do anything with them. And then it has a return. So the return is hey. Then hey is sent back to here, and then the print statement executes hey. So I'll put some breaks so you can see the progression, and you'll notice that it steps through that accordingly. I'm going to put a few breaks. Okay, so I put a couple break statements in. Let's run it and I'll show you how it executes the closure. So we're going to play it. All right, so we're hitting the API call singleton, and it's just about to call the Pokemon function. All right, so it called the Pokemon function, and now it's executing the body. So the first line it hits is let first, and then the next is this one, and then it hits this one, and then jumps over to our closure. And it just recognizes Pokemon in. And so it hits the return hey, and that's a statement that goes back to, oh, I think it'd be more helpful if I do this. Let hey equals completion Pokemons. All right, and then we're gonna print hey. All right. Oops. I don't know why it won't let me put a breakpoint on 11. All right, so we're hitting the API call. Now it's jumping to first line, next line, and now it's going to jump, when I click play, it's going to jump to the closure. All right, so then it hits the hey part, and the returns back to here, and so then we get to print hey. And now when I press play, hey is going to appear right here. All right. So now what we really want to do in here is we want to make a call to the Pokemon API, which is luckily available here. Let me try it out. I'm going to, whenever you're playing with an API, it's good to just put it in your browser. I wonder why it didn't give that many. Let me try. Let's see. Pokemon 2 100. Let's do that. Oh, so it gives you as many Pokemon as you're requesting. Game index 100. Oh, let's see. 99. 98. Huh. Doesn't have the 98th one. That is confusing. Gives a lot of stats. So basically with a lot of APIs, you just kind of have to fiddle around with it and in order to get the things you're looking for, and look at the documentation and put the URLs in your browser, and then take the result and put it in a JSON viewer, such as JSON lint or JSON viewer. And I actually prefer JSON viewer to JSON lint because JSON lint only seems to indent the JSON you give it, and that's nice, but JSON viewer really gives you a visual model. So it's really easy to look at JSON viewer and parse the JSON. So I'm fiddling around with the URL to try and see if it works intuitively and the way I want it to. And we can take that JSON, put it in JSON viewer, and immediately it's modeled. Huh, that worked. So it lets me put in a name. Now I'm going to try a number. And I'm just pasting it in JSON viewer, copying it, and then pasting it, and checking out the viewer. Oops. I'm trying to figure out if it's listing all of the Pokemon up to Pokemon 12. It seems like it's only giving me one Pokemon. Just the Pokemon whose ID is 12, and not 12 Pokemon. So I'm just checking to make sure it's giving me the Pokemon in the right order, or the correct Pokemon for the correct ID. And it looks like it does. So I'm just going to go ahead and get one Pokemon at a time and iterate the Pokemon's ID. Let path equal. Now, make a string, and we're going to delete this part. Now for index in 1 to 20, let URL string equal path string plus index. And let's do it. All right. Completion. And actually, let's just call it after we get. Should we call it after we get everything, or should we let it load? Maybe we'll let it load one. We'll send one Pokemon at a time. We'll see how that works. Oh yeah, so we're gonna instantiate a Pokemon in here, and we don't know this, and we don't know that, and in here, if let error equals error, print we have an API called error, and return. Now, guard let data equal data, else return, and now actually we don't have to do that. We could just do if let data equals data as. Now we just need to check the JSON viewer, and it's going to be a dictionary of, let's scoot that over. So it's going to be a dictionary of type, and I'm going to do command option 0 to get that part to go away, and then command shift Y to make the debugger go. Alright, command option 0 to get the attributes inspector to go away. Command shift Y to get the debugger to go away. Command 0 to get the file navigator to go away. Alright, so we have a dictionary of type string and any. Alright, and now that'll convert this whole JSON tree to a dictionary of type string any. So we want the ID, so we can do if let ID equals data, and then we're going to use a subscript and put in ID to map to it as int. We're going to do one more if let, because if we get the ID, then we also want to get the name. So if let name equal data, name, and then as string. All right, so notice this whole like one scope and then a scope inside a scope and then a scope inside that scope. We could just do it this way. So we could use commas instead, and then we can take away some of this work. And we could take away the if, and we can indent accordingly, and there we go. So I have an extra couple curly braces, and taking them out should take care of that. And now we are going to call the completion handler in here, and we are going to give it the ID, and we're going to give it the name. We have to do JSON serialization. Let JSON equal JSON serialization data Let me check out my other projects. All right. JSON object, not data. There we go, with data. There we go. All right. As all right. Now, because this throws an error, we have to put it in a do catch clause. Oh, what? Oh. This should be JSON. Okay, so call can throw, so we got to put it in. Oh, whoops, flat. There we go. Oh yeah, it produces string, but we don't need it to produce string, so we're going to take that out. And this can throw, so we got to put it in a do catch clause. Do, well, catch. All right. Now I'm trying to figure out why is that indenting it so weirdly. Control I. Oh, that is not right. Oh, I have an extra parentheses. That's why. There we go. Okay, cool. All right. So, ooh. There we go. All right. Now we're going to put this inside here, and life should be complete. There we go. All right, cool. oops, we'll take this out. And what we're going to do is as Pokemon come in, we're going to add them to the array. So Pokemons.append. So if we weren't using if we weren't passing in a closure like this, we would have the information we need, but it would be all the way in the API call. The problem is if we get Pokemon coming in this file, in this class, we won't have access to the table view. But if we pass in the completion, if we pass in a closure, then we do have access, and we can call the closure that we defined here, right here. Here's the definition, and then here's the call to the closure that we defined. So we're going to append Pokemon, oops, dot append, and we're going to append a Pokemon to it. And then after each time, we're going to hit the dispatch queue, which is a class that has a property on it called main, which is a singleton. And we have to use self whenever we are calling a function within a closure from its parent scope. So in here we can write tableview.reload data. So one of the rules is that any modification to the UI should be done on the main thread. We have separated string literal is unused. Is that true? Okay. Alright, so we cleaned it. I'm going to take off these breakpoints. All you have to do is go over here, click delete. So we're calling the API over here, and then we're also, when we get to this completion handler, we're calling it, and then we're coming back here, and it's going to execute the closure that we defined right here. It's going to send in a Pokemon each time we get one, and then it's going to add a Pokemon to this array for each time it hits this, and then it's going to pop back onto the main thread, because when we do URL session, it's creating a background thread. So this line right here is bouncing this stuff onto a background thread, and what that means is the main thread hits here, keeps executing, and goes back over here, executes down to the end of this scope, and then because we call it from here, it hits here, and then it moves on to other background code executions. When we hit that URL session, it actually sets a second thread up on this line to wait for when the response comes back from the server. And then when the response comes back, it starts executing these lines. It goes through and executes these statements, and it does so at the same time that the main thread is executing. So when we get here, it's still on a background thread. That's why we have to pop back onto the main thread and basically override the main thread and run this. And then after this is done, whatever the main thread was doing will continue. So we are filling the array, and the table uses the array right here to fill itself. So then we're running reload data. So after we put Pokemon in here, we reload the table, and it grabs more Pokemon to display. So let's run it. Let's see what happens. All right, cool. So that's exactly what we thought would happen. It's not in order, but that's because the database is not sending them to us in order. So that's okay, and as they come in, we keep getting more and more. So in summary, we were able to separate this code into a model, basically, and separate it from the view controller, and where we are handling the information that the model gives us.